Welcome back, guys, to Jared the Journeyman. Today we're going on to step 3 of the motor load calculations, or the motor calculations. We've gone over 2 steps already, and I'll be putting those videos up, or links to those videos up, and you can go to them. I would strongly suggest looking at those before you attempt step number 3, because you're going to need those 2 other steps before step 3. If you guys are liking what you see, give me a sub. Need some subscribers, so hit that subscription button. And what we can do is I think we've got 3 more videos going on here for this total of 6 videos on this motor calculation. So you'll be wanting to know when those come out. So with that said, let's move on to this one. Let me get this stuff opened up. All right. So here we go again. You guys that have seen my previous videos know how to find the FLC, how to find the overload protection using the FLA. And now today we're going to find the size of the branch circuit conductors. So we know how to do this one. Let me hit the laser again. We know how to do this one. We know how to do this one. Now we're working on number 3. So we're finding the size of the wire that goes from your MCC, your motor control center, over to your motor. So with that, let's go to 430.22. And at 430.22, this is for a single phase motor on this branch. So if what it's explaining is this situation right here, just one motor is on this branch circuit right here. So 430.22 single phase motors. Conductors that supply a single phase motor used in a continuous duty application shall have an ampacity of not less than 125% of the motor full load current rating, as determined by 430.6A1, or not less than the specified in 430.22A through G. So the big takeaway right there, guys, 125% of the motor. So our ampacity cannot be less than 125%. And that's on a single motor. Now, guys, highlight this. Highlight 125%. Now let's go to 430.24, several motors or a motor and other loads. So let's look at this. Conductor supplying several motors or a motor or motors and other loads or load shall have the ampacity not less than the sum of each of the following. So the sum of each of the following, that means you're going to have more than one motor. So the first one is 125% of the full load current rating of the highest rated motor as determined by 430.6A. So guys, the FLC determines this, not the horsepower, the FLC. So we're working off a full load current. So full load code, that means we can go back and look in our code book and find that number. If we the next motor, the sum of the full load current ratings of all other motors in the group as determined by 430.6A. So the smaller motors, we start adding up the FLC on those. And then the third one, 100% of a non-continuous non-motor load. So I have seen this question in master's tests, and they have to tell you that it's a non-continuous non-motor load, and then you still have to have 100% of that. And step 4 is 125% of the continuous non-motor loads. I think the one that came to mind for me was a pump on a swimming pool setup, and then it also had some landscape lighting and something else. So you were having to utilize all this situation to figure out that, and that was my Texas Masters. on that one. Now, another thing I want to point out to you right here, informational notes, see information of Annex D, example number D8. Guys, if you go to the back of your book and look in the informational notes and find D8, it gives you an example of this situation right here on how to work it out. So if this is one of the last questions on your test and you still got 20 minutes to go back and look over this informational note and make sure you did do this correctly, because get back there and look. You can see it gives you numbers. It gives you exactly how to do it. But if you don't know where that's at or how to use it, it's pretty worthless. So keep that in mind too. There's some good stuff back there in those informational notes. All righty, let's go on. Here we go. And what is the minimum conductor required for a feeder circuit that supplies the following three-phase 460-volt motor, each of which has 75 degrees? So right here we have two 7.5 horsepower three-phase motors, two of them. One 10 horsepower three-phase motor, and one 25 horsepower three-phase motor. So what's the minimum conductor side? This is what you do. Full load current, table 430.225 of motors are, 11 amps, 14 amps, 34 amps. So 11 amps on the 7.5 horsepower, 14 amps on the 10 horsepower, and 34 amps on the 25 horsepower. So we take that 25 horsepower at 35 amps. I'm sorry, at 34 amps. I've been saying 35. And you take the highest rated motor multiplied by 125% is 34 times 1.25, and that equals 42.5 amps. And then plus the other 100% of the other motors. So you take your big motor here, and then your two 7.5 horsepowers right here and here. And then we add a 10 horsepower with an FLC of 14. You add those all up and you get 78.5 amps. So I'm going to do this one more time, guys. Let's look up here. We took the 25 horsepower, which is 4.25 amps, and we multiplied it which was 34 amps. Then we multiplied it times 1.25, and it ended up 4.25 amps. Then we took this 10 horsepower, looked up in our book, looked at table 430.250, and that came up with 14 amps here. And then same thing, table 430.250 for a 7.5 horsepower 460 volt motor. And that's 11, and you had two of them. So we got all that figured out, and we came up with 78.5 amps. Now we need to take that, look at the 75 degree column, table 31015B16, and look at, in the 75 degree column, what conductor could handle 78.5 amps. And if you go down, go down to 4, and then go to your center 75 degree, come across, you're going to see that 4-AUG has the ampacity of 85 amps. And that's your answer right there. 4-AUG is the conductor size for the feeder to which you need. And guys, remember, the highest rated motor is the one with the largest FLC, not the horsepower. So keep that in mind, guys. All right. Well, that's how we do step 3. Let's go back to right here. somewhere within your book right here, 430.24 and 430.22. Guys, write you a little 3 there. Write a 3 because 3 corresponds with this right here. And again, guys, there are a bunch of blank pages within your code book, especially in the very back. If you get this information in there with you while you test, that will be great. We get this information and this information. Guys, that's all I've got today. That's step 3 of the motors. We've got 4, 5, and 6, so 3 more steps left on figuring out all your motor calculations. These are the main problems or questions that you will see on your Journeyman's test and your Master's test. So that's all I've got for you guys today. Again, if you liked what you saw, hey, give me a subscribe. And if not, you guys be safe out there.